Okay, so this is where we're picking up from. So notice we do have the ones in blue, and we don't have angle measurements, okay? So what we're going to do is we're going to go through, just like I broke the circle up into the top half into 6 equal parts, we're going to do the same thing, except we're going to break it up into 4 equal parts. Okay, so let's go ahead and draw our circle again. Kind of looks like an egg, but that's okay. So we know that's 180 degrees, which is pi radians. This is 0 degrees, which is 0 radians. So breaking this up into 4 equal pieces, that's just the top, okay? So we know that 180 degrees divided by 4 is 45 degrees. So that means this central angle here is 45, this is 45, this is 45, this is 45, right? So if we start rotating this ray about the center here, this angle here is 45 degrees. This is 45 plus 45. This is 45 plus 45 plus 45. And then obviously halfway around is 180. So we came up with our degrees. With radians, take pi and divide it by 4. It's pi fourths. So that means each little piece here is pi fourths, pi fourths, pi fourths, and pi fourths. So if we add those together, the first part is pi fourth radian. That's all it is. Well, now we have 1/4 plus 1/4. That's 2/4, right? But we saw in the last one, when we counted by 6, that was 3/6. What's true about 3/6 and 2/4? Both reduce to 1/2, right? Add another fourths. We're at 3/4. Add another fourth. We're now at 4/4. And just like when we broke it up by 6, we got to this point and had 6/6, which reduces down to 1. So again, 45 degrees is equivalent to pi fourths radians. 90 degrees equivalent to pi halves radians. 135 equivalent to 3 pi fourths radians. 180 degrees equivalent to pi radians. And what I don't want you to lose sight of is what this means. What is a radian? Don't forget what a radian is, okay? When you look at pi fourths radians, what does that mean? Pi fourths is approximately 0.7854, okay? It goes on forever, right? So this angle here that we're calling pi fourths radians, that's this, right? That means if you take the length of this radius, which we know in our unit circle is 1, this arc right here equals pi fourths of that, which is 0.7854, okay? So let's say this was, I know we call just the unit circle, it's 1 unit. Let's say this was 1 inch. That means the arc here is 0.7854 of an inch, or pi fourths of an inch. So just don't forget that pi fourths has an actual value. Pi halves has an actual value. Think about what is pi halves. That's 3.14 divided by 2, right? So it's about 1.5 something. So that means from starting here all the way to here, it's about 1.5 times the length of the radius, okay? So just don't lose track of that. Pi halves is a number, pi fourths is a number, pi 6 is a number. They're just exact values, okay, for that radian measurement. All right, so now we can continue to break it up into fourths down here. 180 plus 45, you're at 225. Plus 45, you're at 270. Plus 45, 315. Plus 45, you're back at 360. Okay? In terms of radians, don't forget where you left off. You left off at 4/4. 4/4 plus 1/4 brings you to 5/4, right? Plus 1/4 leaves you with 6/4. But guess what? We already wrote that one down. Remember in terms of 6, there was 9 pi 6. That reduces down to 3 pi halves. Add another fourth, you're at 7/4. Add another fourth, you're at 8 pi fourths. 8 divided by 4, 2 pi. So now we know, looking here, 315 degrees, that's equivalent to 7 pi fourths. Once you know the degrees and radians, and I ask you to convert 315 degrees to radians, you know it's 7 pi fourths. You don't have to go through and multiply it by pi over 180 to get that. Okay, we know it is. We just went through and divided it up into those equal parts. So now let's go ahead and put that on our circle up here. So in blue, we have 45. We have, where am I? 135. We have 225. And you have 315. In terms of radians, you have 1/4. You have 3/4. You have 5/4. And you have 7/4. So just like how I said it in the last one, this first one is 45 degrees more than 0, or pi fourths more than 0. This is 45 less than 180, or pi minus pi fourths, right? It's 1/4 less than pi. This here is 45 degrees more than 180, or pi fourths more than pi. This right here, 45 degrees less than 360, or pi fourths less than 2 pi, okay? And this is why I've color coded these, is because notice the ones in blue all have the same ordered pairs. They're all 45 degrees less than or greater than 0, 180, 360, okay? Same thing with radians. They're all pi fourths greater than 0, less than pi, greater than pi, or less than 2 pi. They're all the same distance away when you think how far do you have to travel to get back to the x-axis. Okay, so when you're looking at that, how far does it have to go? Pi fourths. How far does this one have to go? Pi fourths. How far does this one have to go? Pi fourths. How far does this one have to go? Pi fourths. And that's because of the triangles that we placed in there earlier this week, okay, in the recent lesson. Okay, and the last piece is the ones in green, which are your quadrantal angles, which we already did. Okay, we just did them with the 6th, and you saw them come up with the 4ths as well. So this was our 0 degrees. This is your 90. This is your 180. This is your 270 and 360. Notice I always have degree symbols too, guys. Don't forget that. In terms of radians, this was 0. This was pi halves. This was pi. This was 3 pi halves. And then we ended with 2 pi. This picture right here is your final product of your unit circle. Okay? I'm going to cut the video here. In the next video, what we're going to talk about are reference angles. And reference angles are very important because you're looking at this right now thinking, holy cow, how am I supposed to ever know this? Okay? Reference angles makes it doable. Okay? Reference angles, when you come back in the fall for pre-calculus, are going to help you remember this. Okay? Even after a little break off from math, you're going to remember it very quickly using reference angles. Okay, so that's what we're going to start with the next video.